Hey, Mr. Klein here. I am your statistics teacher. Or I'm not your teacher and I'm just a guy that you're going to do a problem with. Anyway, this right here is problem set 3.11, and I'm going to walk you through some of the skills involved in making a scatter plot and finding the correlation using Google Sheets. So let's do this. You can do this along with me. So we're looking at a problem here. Number one, it says copy the columns for height and weight. So let's go over here. Here's height, here's weight. Copy. Going over to number one, and let's paste. Okay, cool. So we got that. And then the first thing that we want to do always is get a scatter plot of your data. The reason that you want a scatter plot is to make sure whether a correlation is appropriate. Remember that if there is curvature in the scatter plot, then the correlation is a number that won't mean anything. So I'm going to highlight these two columns and come over here to insert chart, hit enter, and something's going to happen. That sure looks like a scatter plot to me. Okay, so we're feeling pretty good. Let's see. Height is on the x-axis, weight is on the y-axis. For now, it doesn't matter which axis is which. So if yours are flipped, no biggie. The one thing that is not good about the scatter plot, the way that it looks right now, is look at the weight axis and how it runs from 0 pounds to 250 pounds, but that all of our data is between 200 pounds and a little more than 100. So we need to change that so that we are soaking up all of the y-axis. The way to do that is you select customize, move my beautiful face over here. And let's see, I want to customize the vertical axis. That would happen right here. There's an option to customize the horizontal axis. I'm not going to bother because it seems like Google Sheets has already done a nice job of making sure that it covers the data running all the way from 60 inches tall to 70, whatever that is. Okay, so we just come down here and I'm going to change the minimum value to say 100. And I'm going to change the maximum value to, that looks pretty close to 200. So let's go 200. Oh, that was funky. It just happened. I don't like that at all. I'm going to undo. There we go. Now I can see that I could even stretch it a little bit more. It looks like I could go up to 125. So I might change that to 125. And now the reason that this is a better way to look at the data is now we can see that we have a positive association between height and weight because you can see that there's sort of like a mild positive slope to any line that we would put through this. The other thing that we can see is that there's no obvious curvature in the graph. So calculating a correlation will be appropriate. All right. So that takes care of step number 2. I'll shrink this down a little bit. No one likes a big scatter plot. Let's go to number 3. Based on the graph, explain whether it is appropriate to calculate the correlation for these data. Yes, because there is no obvious curvature in the scatter plot, let's say. Cool. B, calculate the correlation. The directions are up here. I just found these directions by going to a Google search and typing Google Sheets correlation, and this popped up. So, anytime you want to do something on Google Sheets, you can use a search engine to figure out how to do it. This says that we're going to use a formula that is correl, data y, and then data x. Data y and data x mean the ranges. We don't actually care about x and y. If you reverse them, you will get the same result. So I'm going to go calculate correl, and then I'm going to go right here and say, let's make from the 74 down to 60.7. That's my first data set. And then I want to correlate that with, I put a comma in, and then I highlight the second set, and I hit enter. And it gives me that the correlation is 0.54, which we would describe as a moderate, just barely moderate, but a moderate positive correlation between a person's height and a person's weight. Just to drive a couple of points home, first thing, I'm curious, what happens if I change this formula just a little bit? Let's suppose that I accidentally included this cell right here and this cell right here, the cells that have the headings in them. So I'm going to change this to a 1, and I'm going to change this to a 1. And it's going to go, oh, okay, that still worked. Now, let's suppose I do something weird. Let's suppose I change this to a 2 and this to a 3. So the first height does not have a weight that is associated with it. What happens then? Notice that now it's like, I don't think so, Mr. Klein. I can't do that. So you need to make sure that your ranges for both of your data sets are the same. See how both of mine go from row 2 to row 50. The other thing I want to point out to you is that if you do coral of, and then let's choose the weight to go in the first place, comma, the height to go in the second position, you get the exact same result, right? You see 54%, 54%. But here's a goof that I see students make sometimes. They will accidentally put the same thing into both. So they'll be like, I want to correlate the height with, and then they'll copy the same range again, the height. And can you guess what's going to happen if I correlate the height with the height? You're going to get a 1. And of course that makes sense, because the height correlates perfectly with the height. If I know your height, then I know exactly what your height is going to be. So if you get a 1, usually you want to be a little suspicious of that. Right? Okay, so we got that, the last thing here is it says to describe the meaning of the correlation. And so here I would like you to put it in context. There is a moderate positive correlation between a person's height and that person's weight. So knowing a person's height tells you a lot about how they're not going to weigh, but how much they're going to weigh, but it certainly doesn't tell you everything. That's the game. Go ahead and finish the rest of the spreadsheet.